Reliability test in SPSS and Excel for a 5-point Likert scale questionnaire or a survey. The test is based on the Cronbach's alpha equation. Reliability tests in SPSS using Cronbach's alpha equation for a 5-point Likert scale questionnaire or a survey. The test will measure the internal consistency of items and whether the questionnaire is reliable, and if the survey or questionnaire is repeated on different time and date with the same group of participants, their responses will be similar. That's indicate reliability. And the way to evaluate and assess a questionnaire is to perform a reliability test using the formula that has been generated by Cronbach, and it's called Cronbach's alpha equation. That is equal to K divided by K minus 1. K stands for the total number of items or questions, multiplied by a bracket 1 minus the sum of the variance for each individual items, divided by the variance for the total score achieved by the participant. The value that is generated from the Cronbach or Cronbach's alpha ranges from 0 to 1. 0 means that the questionnaire is unreliable, and a value of 1 for alpha means that the survey or questionnaire is 100% reliable. Here in this SPSS, I had inserted data taken from a questionnaire that has been answered by 20 participants who gave their opinions on 20 questions, 20 items, item number 1 to item number 20, and their responses was inserted as a score based on the 5-point Likert scale from 1 to 5. 1 indicates that the participant is strongly disagreeing with the statement or the question. The 5 value reflects a strong agreement with the statement. A value of 3 means that the participant is neutral. To evaluate and assess the quality of the questionnaire or survey, reliability tests based on Cronbach's alpha can be used and performed here in SPSS. The way to do that first is to calculate the total score achieved by the participant, i.e. to count all or add up or combine all the scores achieved or reported by each individual participant for each individual item, i.e. combining the values for all the items for each individual participant. So to do that, to do this first step, first click on transform, then click on compute variable, and in the compute variable we are going to generate a variable or a column of data, and we call it total score. And to do the total score is first to add all the values here, and to do that is to select on the function group, click on all, then scroll down to statistics, and then from statistics use the function or the command for sum. Drag that into the numeric expression. So we're going to combine and add the value for each individual participant. So see here, the command is sum between brackets, and then we are going to add the first item here separated by the comma, and then add the second item. So we're going to repeat separated by comma, and we're going to insert the third until the item number 20. Every time we insert the item has to be followed by a comma. Insert comma, and then item number 7. So we have 2 3 4 5 7, then 8 9 comma 10 for the rest of the items. Item number 14, 15 comma 16 comma 17, and then comma 18, and then item number 19 comma item number 20. So we have placed all the items between the brackets separated by comma. If we click on OK, a new data variable is generated on the far right hand side. This represents the combination of all the scores for each row or for each participant, and I'm going to do a few editing on that column or variable by clicking on variable view, and I'm going to reduce the column width to 6 and make the scores center, and reducing the decimals into 0. Once the total score is calculated for each participant, the next step is to transpose this data, move these items into this side, and then the ID for each participant into the other part here, upper part. And the way to do that is to click on data, transpose, and then in transpose I'm going to select the variables from item number 1, select A, deselect this, and also include the total score variable in it, move it to the variables box, and then in the name variable going to move the ID into that box. And if I click on OK, again a data view is generated. Now the items are in here in this case are inserted in rows, and the student ID is in columns or variables label. And I'm going to do a few editing for this data. Transpose data. The first one is to reduce the column width into 6, and then to align the data into the scores into the center for all the data. And then I'm going to change also the labeling of the variables by clicking on the column here, then control find and then replace, and I'm going to replace the K underscore with an S for student. Replace all. These all has been renamed by labeled as S1 to S20, student number 1 to student number 20. If I close that and go to the data view, again these are labeled here as S1 to S20, and on the column here item number 1 to item number 20 in addition to the total score. So now we had done the second step. The third step is to try to determine the values for each component of this formula. K is the total number of items or questions, which is 20. For the variance for the items or each question, we need to calculate that and then add the variance for all the items together, and then divide that by the total score variance. And if we go back again here to the data view in SPSS, I'm going to calculate the variance for all the items with the total score. And the way to do that is to click on transform, compute variable, and then I'm going to generate a target variable, call it variance, and I'm going to use a function group by clicking on all and then scroll down to statistical and then select the variance command and drag it up to the numeric expression. Again, we're going to do the same thing, calculating the variance for all these variables from S1 to S20, and the way is to insert these between each item between the brackets. Insert the S1 first, separated by a comma. Insert the S2 by comma, S3 and S4 and S5 and then S6 and then 7, 8, 9, 10, 11, 12, separated by comma. Every time you enter a variable, you separate that by a comma, and then 16, 17, comma, 18, comma, 19, comma, 20. So we had inserted all these variables between the bracket from S1 to S20. If I hit the OK button, a value is another target variable is generated on the far right hand side that calculate the variance for each individual item, for item number 1 to item number 20, in addition to the variance for the total score. So the variance for the total score is this value, and the variance for each individual item is this value. I'm going just to do a little bit of editing here by making this into the center and then reducing this into 6 and back again to the data view. I'm also going to reduce the decimals for these scores here by clicking on converting this into 0 decimal, but keeping the variance with 2 decimal points. So we have now most of or all the values for the part of the equation. We have the variance for each individual items. We have the variance for the total score. We need to find out the sum of the variance for all the 20 items. To calculate the sum of the variance for the items, we need to add up all these values. First of all, I'm going to Control X, remove this value from here, place it into the equation here in this equation, as this is the total score variance, and I'm going to replace it here by copy and paste, and back again to the data view here, and to calculate the sum of the variance for the items, click on analyze, click on descriptive statistics, click on frequencies, and then click on statistics and select the sum command here. Click on continue, and we're going to calculate the sum for the variance column or target variable, and I'm going to untick the display of frequency. If I click on OK, a table here generated showing the sum of the variance for all the items from item number 1 to item number 20, which is equal to 27.1 approximately. So I'm going to, and this represents the upper part of the formula, so it is 27.1. So far we have calculated the variance for the total score and the sum of variance for all the items. The next step is to calculate and determine the Cronbach's alpha following the equation as given here in this formula. For K here, K represents the total number of items, which is 20, divided by 20 minus 1 equal 19. At this stage we need to use a calculator. Here I have a calculator, and I'm going to use the calculator to determine the Cronbach's alpha value. We need to calculate the value between these two brackets. 1 minus 27.1 divided by 119.63 equal to this value, and we're going to multiply that by 20 equal, then divide that by 19, and a value of 0.81 is generated. So the alpha value here is equal to 0.81. What does this value mean? This value means that the questionnaire or the survey is 81% reliable. The table here shows the Cronbach's alpha value and the level of reliability. If the alpha value is equal to 0.9 or greater, then the reliability is excellent for a questionnaire. If a survey has a Cronbach's alpha of a range between 0.8 and 0.89, then the reliability is good. Reliability will be acceptable when the range for alpha is between 0.7 and 0.79 or 0.79. The questionnaire will be considered questionable when the alpha value is in the range of 0.6 to 0.69, and the survey would have a poor reliability when the alpha value is between 0.5 and 0.59, and the questionnaire or a survey will be unacceptable or unreliable when the Cronbach's alpha value is less than 0.5. So this is the way to evaluate and assess the reliability of a questionnaire or a survey based on the Cronbach's alpha equation. Reliability test in Excel for 5-point Likert scale questionnaire or survey using the Cronbach's alpha equation. The equation is given below as alpha equal to K divided by K minus 1. K stands for the total number of questions or items in a survey or a questionnaire. then this is multiplied by a bracket 1 minus the upper part of the formula is the sum of the variance for all the items, the sum of the variance of the items or questions, and that value is divided by the variance for the total score. So the reliability test is a way of measuring the internal consistency of an item. It will test how reliable is the questionnaire or a survey if it has been repeated on a different date and different time with the same participant. Their score or their response will be similar in different time period. That is the essence of doing reliability test for a questionnaire and a survey. It is an essential step, a preliminary step when an individual is designing a questionnaire or a survey to test how reliable is the survey or the questionnaire, or as a whole the whole survey. The way to do that in Excel, I have here inserted a sample of a response taken from a questionnaire or a survey that has been given to 20 participants answering 20 different questions or items from item number 1 to item number 20. And the score or the responses of each individual participant was scaled on the 5-point Likert scale from 1 to 5. 1 indicates that the participant is strongly disagreeing, and a value of 5 means that the participant is strongly agreeing, and the value of 3 reflects a neutral response toward the item or a question. So here we have a data that is called ordinal, so it's an order from 1 to 2, 3, 4, 5. And to determine the reliability of the test, to perform a reliability test for this survey or questionnaire, we're going to use the Cronbach's alpha formula given here. And the way to do that is, first in this column, going to generate a new column or data, call it total score. So in this column, we're going to calculate the total score achieved by each individual participant, i.e. combining the scores or the responses from each part for each individual participant for all the questions. And the way to do that is to click on the cell here, then click on the sum here, and then select the range from item number 1 to item number 20 and hit the enter key. A value of 51 is generated. To autofill and auto-calculate the total score for the rest of the participants, select the cell here, drag, hold and drag, and then release. A value is generated for each individual participant. The next step is to calculate the variance for each individual item or question, and then the variance for the total score. And the way to do that is in this cell, insert the equal sign and then type variance and select the variance S for sample. So we are going to select the variance, calculate the variance for a sample, as here we have a sample. If you double click on that and then select the range of the data for the 20 participant here for the item number 1 and hit the enter key, a value was generated for the variance for the first item. to auto-fill and auto-calculate the value of the variance for the rest of the questions. Select, hold, drag, and I'm going to drag it toward the ends, as we are also here going to calculate the variance for the total score in addition to the variance for each individual item or questions. So now we had calculated the total score variance, and then we have calculated the individual variance for each individual item. The next step is to add the variance for the items, so for these 20 items. And the way to do that here is select this cell, then click on this sum symbol, and then select the range for the value to add all the variance together. And if you hit the enter key, a value is generated for the sum of the variance for the items. And since we have here the variance for the total score, I'm going to select, right click, copy, and then I'm going to paste that here next to this symbol of variance for total score. And if I click on the link here, the value is inserted in this cell, and I'm going to label this as, let's call it I or T for total, since it's a total. So we're going to select this, and hopefully we try to make it a subscript. Click on OK. So we have now the value for this total variance for the total score. For the K represent the total number of items or questions, and since here we have 20, I'm going to insert number 20. So now we have all the values for calculating the Cronbach's alpha and the value for all the part of the equation or parts of the equation. The way to calculate and determine the value for the Cronbach's alpha: in this cell, insert the equal sign, and then open a bracket, add 20 divided by 19, close the bracket, insert a multiplication sign, then open a bracket, insert number 1, then minus sign, then select the upper part value of the formula, which is this one. This will be divided by the lower part, which is the variance for the total score. Close the bracket and hit the enter key. A value of 0.81 is generated. This value here, which I'm going to label red, is the reliability value, Cronbach's alpha value. So what does this value mean, 0.81? This value means that this survey is 81% reliable. If we refer this value into this table and look at this table, which shows the Cronbach's alpha value and the level of reliability, as we can see here, when the alpha value is equal to 0.9 or greater than 0.9, then the questionnaire or the survey is excellent in reliability. A survey is considered to be good in reliability if the value of alpha is from 0.8 to 0.89, and a questionnaire is acceptable when the value is from 0.7 to 0.79. A questionnaire is questionable in reliability when the value for alpha is from 0.6 to 0.69, and the reliability is poor when the value ranges from 0.5 to 0.59, and the survey will be unacceptable. The reliability will be unacceptable, or the survey is unacceptable in reliability when the value for the alpha is less than 0.5. And since our value here is 0.81, which is in this range, so the survey or the questionnaire have a good reliability. So this is the way to perform a reliability test in Excel and generate a value. The value of the reliability is based on the Cronbach's alpha formula given here, and the value ranges from 0 to 1. 0 means that the survey or the questionnaire is unreliable. 1 means that the questionnaire or survey is extremely reliable. And